So today, for this DigiSnack, this is about code coverage. Let's start first very quickly. So my name is Rachid Laris. I'm in charge of the HDL product line. As you can see here in the slide, the yellow circle, this is where Catalog has offices. And also, for example, in Italy, in France, in Spain, and in Germany, we also follow our customers in China for manufacturing purposes. So let's see the slide. This is a research study from Research Wilson Group. Here we are comparing and contrasting Europe with the rest of the world in terms of adopting various dynamic verification techniques. So we can see here that we have code coverage, assertions, functional coverage, constant random. So code coverage and functional coverage sounds to be very important in this study for Europe and also for US. And now let's focus today on code coverage. So the question is, what is code coverage? In general, code coverage is the percentage of your verification objective that have been met. So there are two types of coverage. We have the coverage that is automatically extracted by the tool for the design code, which is code coverage. And we have the coverage developed by the user to link the test bench to the design functionality, which is functional coverage. Code and functional coverage are not the same, and you need both of them, of course. So code coverage is an automated technique that identifies code that hasn't been tested, but it doesn't tell you anything about functional correctness. It just tells you if the code was executed, exercised, or not. It does not require a change to your current design and simulation approach. This means that you do not have to modify your RTL or test bench code, and you do not have to write any additional code. The only thing you have to do is to add a switch to your compilation step and also another switch to your simulation step. In the following slide, I will go through the different type of coverage and will show you how you can use them. So the first, and in my opinion, the easiest type of code coverage is statement coverage. Statement coverage counts the execution of each statement on a line individually, even if there are multiple statements in a line. A statement always ends with a semicolon. There are different ways you can debug statement coverage. If you look at line 167 here, as I can show you in this line, you see two statements in one line. The green mark here in the source code window, you see that both statements are covered. In the coverage detail and in the coverage analysis window, you see statements individually. So you can see how often they were hit. So you have more details in the coverage analysis and in the coverage details about this statement. The second type of coverage is branch coverage. Branch coverage counts the execution of each conditional if then else not executed. The analysis window are the same as for statement coverage. Here you see an example of a branch coverage, as you can see here in this branch coverage here. And you can see that there is no else path. But the else path is counted in the all files here. Another type of code coverage is FSM, which is finite state machine coverage. So FSM coverage counts the state, transition, and path within a finite state machine. Beside the coverage details on the code coverage analysis window and detail window, you have also the FSM visualization in graphics. A little bit harder to analyze is condition coverage. Condition coverage analyzes the decision made in if and ternary statement and can be considered as an extension of branch coverage. In line 137 here, you can see the red X, which means that this condition is not fully covered. So the coverage details, as you can see here, gives you more insight what was and was not covered. Let's quickly go through this example. You can see two tables, this one and this one. The first table report coverage on a per input basis. In this example, we have two inputs. The first one is the MSB, most significant bit of exponent 10. Okay, here, signal equal 1, and the second one is exponent 10 signal equal 0. So the first one, the first input is fully covered, but the second input has a coverage hole. The second table goes a step deeper and expands each input into coverage bin. In walking through this table, you can see how focused expression coverage ensures that each input has been shown to independently affect the condition output. So in row 1 here, you can see that if the MSB of exponent 10 is not 1, I mean true, affect the condition output only of the non-masking condition exponent 10 is not 0 is true. In row 2, you can see that if the MSB of exponent 10 is 1, you do not need any non-masking condition because this input already affects the output. In row 4, you can find the coverage hole. The exponent 10 was never set to 0. The last type of code coverage is toggle coverage. Toggle coverage counts each time a logic node transition from one state to the other. In this example, exponent B here is a standard logic vector 9 down to 0. In the code coverage analysis window, each bin is displayed individually. The coverage detail window shows you here the whole signal, the node count, and the number of transition. You see that only 18% of this cover item is covered. If you select a single bit of the signal, you will get the coverage details in the specific bit. Note that exponent 8, exponent B8 is excluded with a mark E from the coverage. This is marked with the E, yes. So in such exclusion can give you up to 100% for your code coverage. So how we use the flow, as I already mentioned before, you do not have to change anything in your RTL or test bench code, the usage flow. You can apply code coverage to a specific source file in the design by adding the plus cover switch to the compiler command. BCESFT, as you can see here, this stands for branch condition expression statement, FSM, and toggle. You simply add the type of coverage to the plus cover command which you want to collect in that example. I want to collect all type, etc. So you can also apply code coverage to the entire design. Here you see minus coverage to the top. Questa gives you more flexibility in applying the code coverage. You can apply code coverage for a specific module. For example, here we apply this coverage type for module A, but only statement coverage for this module. So let's go quickly for a very quick demo. So I have a small, very small example here. So let's, okay. So as you can see here, we have the compiled module. This is a memory example. So I just need to compile underscore cover. You can see this is a do file. I have plus cover, mean I use all the type applied to this VHDL file. I do compile underscore cover dot do. Now I load the design with vsim minus coverage, the test bench in the work library. This load my design. So this, okay, so we can do the design here after compiling. I will show you how the do file I'm using to log all the signals, log minus R star. This log all the signals in the wave window, and I add some specific signals in my wave window. Okay, so I just, okay. So here, for example, I can see my FSM, my state machine. I can double click here. I can show the graphic of my state machine in Modelsim. I go back to the wave window so I can see all the logged signal in my simulation. So I just need now to run minus all to run my simulation. So the simulation ended now. We can see all the signals. We can see the source code. So you can see different color here in the source code. You just need to hook the mouse, and you can see on the left the green mark that shows the line covered and the number of time it's heated, as you can see. We can go to the source here. We can do what we call annotation of the source code, so we can see embedded in our source code the values of the signals or the vectors already in the source code, so we don't need to go to the waveform to check the values. So this is a nice feature. We can see a pink area. This is not covered code. As you can see, we have X's in front for pink area. This is of course available for all the source code. Now let's look for the analysis window. We click in the analysis window. We have a filter. So we have, for example, the green checked area, and we have X's, which is the non-executed area. As you can see, hit 0 for this line, for example. We can switch to branch, and we have all the branches, and the branch with X, we see the value here. Of course, if there is expressions, you can have expressions, you can have conditions. You just need to select, and the detail window shows you the tables. If you remember in my presentation, we have this condition here, and you have the details of these two inputs, and we have 100% coverage here. So we can also go back to statement. We can select any line. We can make an exclusion directly on the GUI, so we can see the mark E that shows the exclusion, and of course we can cancel this exclusion from the statistics. Now the second step is to do a kind of saving coverage data. So we go to coverage save. We choose the type of data we want to save. We give it a name, for example, test for underscore UCDB. UCDB stands for Unified Coverage Database. And then we will see how we can analyze and manage different results of code coverage. So, for example, we open the browser here, right mouse click button, and we have add file. Add file allows me to add different previews, saved result of code coverage. Is code coverage result is specific to a specific test, and now I can do, for example, I select all my result. I can do either a ranking. I can make a ranking between this test based on the performance or CPU time, or I can do a merge. For example, I can merge to see one global code coverage statistic for my whole design. So as you can see here, so this is the global coverage. We can also see the result in the files. Okay, so we have the files in my design. I don't have so much. So you can see different type of coverage with some histogram with different color that shows you exactly the average coverage that you get. So you can personalize the how you can display this column. So for example, here we can filter, so we can reduce the number of columns if not necessary. Now the second step is to generate report. So report, we can have report, you can see it in text or in text, for example. So you can just filter a little bit, and you can, for example, decide to do all the code coverage. Okay. And then you say, okay, this will open the window with all the details in text. We can also do the, how we say, the HTML code coverage, which is very important. And in here we can decide to share the source code or not. So here we are not activating the source code. Okay. So we just click OK. Now we can see the HTML report. Okay. So this is HTML report. We can have details by instance or by design. Okay, so we have different details. So I think the time is over now, so I will stop. Of course, if you need any further details, or if you want to go in more deeper, so let's stay in touch, and I'll be available for you. Okay, so this and my presentation. I don't know if you hear me or not, but if there is any question, please send it back. I will be happy to answer your questions. Oh yes, I have a question. I remember this is about simulation that take very longer to finish, and it was not easy to collect some specific event that takes longer to simulate in reality. So in this case, either we can do check and restore feature. This is only available in Questa, not in Modelsim. This allows you to run a first simulation, and you how we say, you make a record of the early phases, and when the important events start to happen in the simulation, so we the next time we only start the simulation from this specific point. We don't need to cover all the initialization phases, but the condition here, the test should be all in the same configuration. We can do it for the same test, and then we can run code coverage. But for this complex simulation that takes longer and have some important event that you want to collect, event means a specific behavior. So in this case, I can advise to go for functional coverage or using assertions to collect and control and make sure that this specific event happen, and so on. So we can go in more details in this, but I can advise either for using assertion with functional coverage, or even with formal approach. Hope I answered the questions. We can go in more details later if possible. So thank you very much for being present here, and stay in touch in case you need more details. Thank you very much.